In this video here, I'm going to do a quick review of a few of the geometry ideas that are going to come up really frequently in the course. There's going to be a lot of looking at diagrams and just being able to like see, oh yeah, clearly these two angles are equal to each other or something like that, which is going to be drawing from geometry, which is another thing that I'm sure you've had to take at some point in your life, but you might be a little rusty on. So like, for instance, here's a picture in the lecture notes where I have three lines which are all intersecting with each other. And importantly, the two lines that are kind of horizontal-ish are parallel to each other. Just bring up my pen tool here. So this line here and this line here are parallel to each other, which is something that comes up quite frequently, as you'll see in problems. So I have a total of 8 angles marked here where all these different lines intersect. So which of these angles have special relationships with each other? Let me go over a few of the relationships that come up a lot. 1, angles that are opposite of each other across an intersection are equal to each other. So for example, alpha 1 and alpha 3, those guys are equal. This is referred to as two angles being vertical. Because they're opposite of the intersection, they're basically mirror images of each other, and so they have to be equal in terms of the number of degrees. Similarly, an angle like alpha 3 with beta 1, those guys are equal to each other. And the reason why is very similar. Although they're not on the same intersection, they are still mirror images of each other, because well, you can sort of see how they look similar in the picture here, because basically the two lines that are intersecting at alpha 3 are essentially the same two lines that are intersecting at beta 1. So those two angles are also equal to each other. That's referred to as being alternate interior angles. Alternate because they're on opposite sides of the intersecting line, and interior because they're on the inside of the, this is the interior in here, and this would be the exterior out here. So those are alternate interior angles. Another example would be alpha 3 would also be equal to beta 3. Those are referred to as corresponding angles. Corresponding angles mean that they're not even just mirror images of each other, they're exactly the same actually. Because since the two lines are parallel, this is really just the same intersection. Like if you were to take a pair of scissors and cut this picture here and just move one on top of the other one and overlay them, they would be identical. So beta 3 equals alpha 3, beta 1 equals alpha 1, beta 2 equals alpha 2, beta 4 equals alpha 4, because it's the same 4 angles actually. So that's corresponding angles. And there's also, just like there's alternate interior angles, there's also alternate exterior angles. It's the same concept, except you pick two angles that are on the exterior of the intersections, like alpha 2 and beta 4 are equal because those are alternate exterior angles. Again, alternate because they're on opposite sides of the intersecting line, like one's on this side and one's on this side. And exterior because this is the interior down here. Okay. Also useful to know is straight angles. In addition to all the angles that are equal to each other here, we've got some angles that have simple relationships to each other. Like for instance, if you look at alpha 1 and alpha 2, you'll notice that alpha 1 plus alpha 2 has to give you a straight line, because it has to get alpha 1 plus alpha 2 gets you all the way from here to here, and that's 180 degrees. So alpha 1 plus alpha 2 equals 180. An angle of 180 degrees is referred to as a straight angle. You can also have the same concept. It's not shown in this picture, but you can also have the same concept in a right triangle where two angles have to add up to 90 degrees. Those are some of the most common kind of geometry relationships that you see in a lot of problems. Again, hopefully hopefully you've seen this before because it was a little bit quick, but maybe this jogs your memory a little bit about what are some of the special relationships that we use really often.